Today we are going to talk about logarithmic differentiation. And before we go into this topic, I want us to understand or remind us of some basic rules of logarithm. So the first one is the addition rule. When we have log AB base 10, this can be written as this: log base 10 A plus log base 10 B. Okay, so when we have a natural log of the product of A and B, this can also be written as natural log A plus natural log B. You understand? Okay, let's proceed to the second law. When we have log A all over B base 10, this can be written as log A minus log B base 10, and this also is in base 10. Okay, so if I have natural log A divided by B, this can also be written as natural log A minus natural log B. You understand? If I have log y base 10 equals to x in logarithmic form, this can be written in index form as 10 raised to the power of x equals to y. Okay, for we have log a raised to the power of x. This can be written as x log a. You understand? So if you have ln a raised to the power of x, also natural log, we're going to have x ln a. Oh, sorry, it's ln x ln a. Okay, having known the basic rules of logarithm, now let's try to write this out for question 1. Let's look at expand this on log x squared all over 2x. Don't forget that the division sign, we have a division sign, so this can be written as ln x squared minus natural log 2x, as you can see like that. So let's look at another one. Let's assume that we are given 2x squared all over 5x. We are told to expand this. Don't forget the basic approach. This will be ln 2x squared minus ln 5x. Okay, let's look at another one. Let's assume that we are given question 3. We are told to expand ln 4x 5y. This can be written as ln 4x plus natural log 5y. You understand? So we're going to proceed to another one now. Please, I want you to pay attention. Okay, let's try to expand this. Don't forget that the sign between the numerator and the denominator is division sign. So if I have ln a over b, this can be written as ln a minus natural log b. You understand? So okay, let's try to use the same approach in this place. So for the numerator, I'm going to have ln x squared and x raised to the power of 6 sine square x, and that will be minus ln the cube root of x squared plus 2. You can see like that. Okay, however, this is not the final expansion. You can see that I still have the product. I have a product between x raised to the power of 6 and sine square x. You understand? So I'm still going to use the addition rule when we have something like ln AB. Don't forget, I told you that this is equals to ln A plus natural log B. You understand? Okay, now let's use the same approach on the left hand side. As you can see, we have the product of x raised to the power of 6 and sine square x. So I'm going to have, for this side, I'm going to have ln x raised to the power of 6 plus ln sine square x minus ln natural log root of x squared plus 2. You understand? However, I want to tell you that sine square x, this sine square x is also the same thing as what? Sine x raised to the power of 2. I think you understand. When you have something like sine square x, this is also the same thing as sine x raised to the power of 2. So I can still proceed to expand the sine square x. For this, I'm going to have ln x raised to the power of 6 plus ln sine x raised to the power of 2 minus, you can see that this is a cube root of s squared plus 2. So I can write it as this ln x squared plus 2 raised to the power of 1 over 3. I think you understand to this point. Okay, don't forget that I told you that if you have ln a raised to the power of x, this is also the same thing as what? Natural log x multiply a. You understand? That is the power, we multiply the coefficients before the natural log, and then we are going to have something like this. Okay, let's use the same approach in this place. I'm going to have 6 ln x plus, and then for this I'm going to have 2 ln sine x, and then minus 1 over 3 ln x squared plus 2. You understand? Now if I ask you which one is easy to differentiate between this question and this question, of course it is this, because that's the reason why I'm trying to teach you how to expand your when you are given natural log function and you are told to differentiate the natural log function, you can just break it down, you understand, so that you'll be able to differentiate it. Okay, now let's take another example. Let's try to expand this. Let's try to break it down. You can see that the sign between the numerator and the denominator is a division sign, and I told you that when we have a natural log of division of a over b, it can also be written as this. So we are going to use the same stuff. So I'm going to have for this x squared root of 5x, you understand, minus natural log of sine x cos x, no, sine x cos x. Okay, now you have taken the first step. The second step, you can see that there is a product sign between x squared and root of 5x. So, and I told you that when we have a natural log of the product of a and b, they can also be written as natural log of a plus natural log of b, that is additional root. So I'm going to have natural log x squared plus natural log root of 5x, okay, minus, also you can see the sign between the sine x cos x is product. So I can also write this as natural log of sine x minus natural log addition sign plus natural log of cos x. Okay, now don't forget that I told you that when we have a natural log of a function that has an exponent, this x will multiply the coefficient. So I'm going to have for this can also be written as ln x squared plus natural log of the 5x can be written as this 5x raised to the power of what? 1 over 2 minus ln sine x plus natural log of cos x. You understand? Okay, now this can be written as 2 natural log of x plus 1 over 2 natural log of 5x minus natural log of sine x, and if this negative multiply the positive here, I'm going to have minus natural log of cos x. Trust you understand, we have been able to break this down to this. So now let us proceed. Okay, let's start by knowing the rule of how to differentiate a logarithmic function, natural log function. Okay, let's assume that we are given a y is equals to ln u, and we are told to find the derivative of y. The derivative of y is equals to 1 over u multiplied by derivative of u. You understand what I'm saying? That is, we are going to take the inverse of the function of the of the parameter that is here, we are going to take the inverse and then differentiate the parameter that is here and multiply it with the inverse. That is how to find the derivative of a logarithmic function. Okay, let's assume that we are told to differentiate y is equals to ln x. The derivative of y is equals to ln x can be dy all over dx is equals to, don't forget the rule, we are going to first take the inverse of the parameter that is here, and if you compare this question with this question, you can see that u is equals to x. So I'm going to have the inverse of x, which is 1 over x, multiplied by the derivative of x. And if you find the derivative of x, this will be 1 minus 1 multiplied by 1. You understand? So dy all over dx is equals to 1 over x. So the derivative of ln x is equals to what? 1 over x. That is what? Example 1. Okay, let's move to example 2. When we are told to find the derivative of y is equals to ln 2x squared plus 5. Don't forget the approach. U is equals to what? U is equals to 2x squared plus 5. The derivative of u, which is u prime, is equals to what? 4x. So according to the logarithmic differentiation rule, I told you that we are just going to take the inverse of the parameters that is here. So I'm going to have the derivative of y is equals to 1 over the parameter that is here is what? 2x squared plus 5. So this will be 2x squared plus 5 multiplied by the derivative of u. The derivative of u is what? 4x multiplied by 4x. So the derivative of y is equals to 4x all over 2x squared plus 5.